Again, I can't stress it enough. So please always remember what it is exactly we're looking for. In this previous video, we were able to compute the number of moles of nickel. However, it's not nickel we're after. It's bromide and the bromate. These moles of nickel that we'll find, we have to find a way to be able to tie it in as to its amount with the amount of that particular thing we're looking for. And as it turns out, we already have the equation right here. That nickel is going to be produced when the bromide is precipitated as HgBr. So we have this particular relevant equation that we're gonna be using right now. So we should convert the moles of nickel that we'll find into the amount of silver bromide that was initially produced by precipitation. So for every 2 millimoles of silver bromide, as we've noted, 1 millimole of nickel is being produced. Plug this into your calculator, you're able to get the amount of silver bromide that was precipitated from our 25 ml alico. So from our calculator, we're able to get a value of 1.12 millimoles of silver bromide that came from our bromide in the solution. So this 1.12 millimoles, we find it in the total of the alico, which is 25 ml. So we have to divide the two. The total number of moles of the silver bromide divided by the volume of the alico that we have. We take note that this silver bromide has, from looking at its chemical formula, 1 millimole of bromide ion present. And so we're able to get the amount of bromide ion. After all, it's not really the HgBr we're after. What we're after is the Br minus. So from this, we're able to compute that there is 0.045 millimoles of bromide ion for every ml of our alico. This is one of the things we're after. So that's why I've already underlined it for us to use later. So we've done all that we can for the 25 ml alico. Now it's time to focus on the information from our 10 ml alico. We did this one first because only the bromide is present in here. We do this one last because, as noted, it's not just the bromide that is in play, but the bromate is also already imported in the computation. So we want to keep this at the very last portion, when the two analytes are already present and will affect the computation. So we'll do this one next, on the next page. So if you've read the problem carefully, the bromate ion was first converted into the bromide ion. Once the bromate is turned into the bromide that was formed will then become HgBr. So what we want to do now is to be able to compute just how much HgBr was formed by the bromate only. Again, the same equation that we had earlier for the titration of the nickel is useful in here. We start off with our very useful pair of information. The volume multiplied by the concentration will always give us the number of moles of whatever that particular reagent is, which is very